Hello, welcome back once again. And then thank you very much for sticking around to this time. I really want to appreciate you and then say a very big thank and God bless you for taking your time to listen to this content. Yes, I'm very, very, very grateful. Okay. So the last thing I want us to look at for today is when you have a simultaneous equation which involves exponentials or exponential equation. Now, when you are given a question and you realize that the question has some exponential equation or the elements of exponentials in it, quickly apply the law of indices, which talks about how to deal with the exponential equation, which I would do in the subsequent this in the subsequent videos. See me talk about indices and logarithms if possible, so that we can further understand one or two things which we are missing. So when you have a situation like that, make sure that you apply the law of indices to the question, and after applying, you realize that you are going to have a solution which will be in a linear form. And then when you get it in a linear form, from there it is very easy to work with it like the normal one. When you have it in a linear form, very easy to either use your substitution, your elimination, or your graphical method. The graphical will come after all these examples. Alright. So please, I know you are expecting something on the graphical, but please take your time. It will come very soon. It may be the next content that I'm going to create. Okay. So let's take one or two examples on this. And then after that, I give you one or two to try as well. Okay. Thank you. I have two beautiful equations on the board. Yes, I mean beautiful. Two beautiful equations on the board. The first equation reads as 3 raised to the power 2x minus y is equal to 27. And the second one also reads as 4 raised to the power x plus y is equal to 1 over 2 raised to the power 6. When you have a situation like this, quickly check to see if your bigger number can be expressed as or it check if it can be expressed in terms of the smaller number or as a prime of the smaller number. Okay, and even if the bigger number you have is not a prime number, make sure that you are getting a prime number from the bigger number which can raise to another power to give you the bigger number. Or when you have two sets of numbers in indices, check to see if they are prime numbers. If they are not prime numbers, then try to get a prime number times itself or times a number of times that it can be able to give you that particular number, and then from there you can pick it from there. Okay, so let's take this quickly. This is a prime number. Obviously prime number. This is 27. We can try and reduce 27 to, let's say, base 3. Yes, base 3 and maybe a power. So we have 3 raised to the power 2x minus 1 is equal to 27 in terms of base 3 is 3 raised to the power 3. Meaning 3 times 3 times 3 will give us 27. We can call this still as equation 1. And then we come to this side too. Now this is not a prime number, this is a prime number. So we can try and express this in terms of this one. So we have 2 raised to the power 2, which is giving us 4 times x plus y should give us 2 raised to the power negative 6. In indices, we're told that when you have 1 over a, it is the same as a raised to the power negative 1. So that is what I just applied over here. Okay, I can call this equation 2. Now from here, since the bases are the same, I equate the powers. So I have 2 x minus y is equal to 3. I can call this equation 3. And then from here to I'm going to have 2 into bracket x plus y is equal to minus 6. I can call this equation 4. Now I can divide this by 2, giving me x plus y is equal to minus 3. Still equation 4 if you want to call it that way. Now from here it is very easy to eliminate y since the coefficients over here are the same. We can eliminate it easily without much difficulty. So let's do that. We have 2x minus y is equal to 3, which is equation 3. Then we have x plus y is equal to minus 3, which is equation 4. Let's add since the operations are different. Let's add. So if I add, I'm going to get 3x is equal to 3 minus 3, which is 0, or minus 3 plus 3 is 0, which means that x is equal to 0. Now if x is equal to 0, we put it into one of the equations, then we get the value of y. That will be x plus y is equal to 3. Obviously, we can see that this is going to be 0 plus 3 is equal to 3. Y is equal to 3. Therefore, x is equal to 0. And then y is equal to 3. If I do 2 times 0, it still gives me 0 minus 3, which is giving me the. So 2 times 0 will give me 0 minus 3. That should give me a negative answer. So let's check our work very well. So the here is supposed to be negative. Yes, and here will be negative. So we have this negative. So we have 2x minus 3. That will give us positive 3. Then we have 0 minus 3. That will give us negative 3 for this particular one. So we say therefore x is equal to 0 and then y is also equal to negative 3. So I'm going to give you assignments. I provide the answer for one of them and then you work it out for me nicely. And then I'll see you next time. Alright. So over here your y is going to be negative 2 and then your x would be x would be 4 and then your y would be negative 2. When you work it out properly you get 4 and then negative 2. That is just the first one. This is the second one too. So the second one reads as so with the second one, it is only one of the equations that has the exponential in it. So on this note, I would like to say a very big thanks to everyone for staying around to this time. Thank you very much. Recommend to a friend, subscribe, and then share your comments, whatever you want us to improve upon. We are welcome to suggestions and critiques.